Hey guys, welcome to my channel. Today we are going to learn about probability distribution. So let's check what are the topics we are going to cover in this video. So they are what is probability distribution and types of probability distribution. In that we are going to learn about normal distribution, binomial distribution, Poisson's distribution, exponential distribution, and probability density functions, cumulative distributive functions, and moment and measure of central tendency, CQness and kurtosis, application of probability distribution, and conclusion. So let's get started. What is probability distribution? Probability distribution is a fundamental concept in statistics and data analysis. At its core, it is a mathematical function that describes the likelihood of different outcomes in a random event. In simpler terms, it tells us how likely it is for an event to occur in a given set of possible outcomes. But why it is important? Well, probability distribution has practical applications in real life. For example, it can help us predict the probability of stock market crash or likelihood of occurring of an earthquake in a certain area. It can also be used to model the spread of disease or the success rate of a new drug. By understanding the probability distribution, we can make better decisions and manage the risk more efficiently. Types of probability distribution. So, there are different types of probability distribution. They are the probability distributions can be categorized into main two types. One is discrete and one is continuous. Discrete probability distributions are used to model random variables that can only take on a finite or countably infinite number of values. So in this we have a finite or countable values. It is called discrete and such as the outcomes of a coin tossed or the number of defects in the batch of products. Example of discrete possibility distributions include binomial distribution, Poisson's distribution, and geometric distribution. On the other hand, continuous probability distributions are used to model random variables that can take on any value within a specified range, such as the height or weight of the population. Example of continuous probability distributions include normal distribution, the exponential distribution, and the beta distribution. These are the distributions are characterized by the probability density functions PDFs, which describes the relative livelihood of observing different values of the random variable. So coming on to normal distribution. The normal distribution, also known as Gaussian distribution, is a bell-shaped curve that is symmetric around its mean. It is characterized by two parameters. One is the mean, which represents the center of distribution, and the standard deviation, which measures the spread of variability of distribution. The normal distribution is important in statistics and data analysis because many natural phenomena such as height, weight, and IQ scores follows the distribution. Additionally, the central limit theorem states that the sum or average of large numbers of independent random variable will tend to follow a normal distribution regardless of their individual distributions. This makes normal distribution of a powerful tool for modeling and analyzing complex systems and processes. So coming on to binomial distribution. Binomial distribution is a probability distribution that describes the number of success in fixed number of independent trials, where each trial has only two possible outcomes, success or a failure. It is widely used in statistics, in inference, and hypothesis testing, especially when dealing with cat- cartographical data. Example, suppose we want to know the possibility of getting exactly 3 heads in a 5 coin tosses. We have modeled this situation using binomial distribution with parameters n is equals to 5 and p is equals to 0.5. The possibility of such success, the possibility of mass functions of the binomial distribution gives us probability of getting k successes in n trials and can be calculated using formula p of x is equals to k is equals to n chooses k, which is into p to the power k into 1 minus p to the power of n minus k, whereas n chooses k is the binomial coefficient. Coming on to Poisson's distribution. The Poisson's distribution is a probability distribution that models the occurrence of rare events such as accidents, defects, or failures. It is named after a French mathematician, Simon Denis Poisson, who first introduced it in 1837 to study the number of errors made by the clerks when copying manuscripts. The Poisson's distribution has several important properties such as the mean, variance being equal, and probability of an event occurring in the given time interval being proportional to the length of interval. It can be used to estimate the likelihood of rare events happening in the specified period, such as the number of car accidents per day on a particular road. Exponential distribution. The exponential distribution is a probability distribution that models time between events, such as waiting time or failure times. It is often used in rare reliability engineering and queuing theory to predict the behavior of systems over the time. The exponential distribution has single parameter lambda, which represents the rate at which events occur. The probability density function of exponential distribution is f of x is equals to lambda into e to the power minus lambda into x, where x is the time between the events. Cumulative distribution function of the exponential distribution is f of x is equals to 1 minus e to the power minus lambda into x, which gives the probability that an event occurs within the certain time period. Coming on to probability density function, PDF. Probability density function is a mathematical function that describes the relative likelihood of observing a value in continuous distribution. In other words, it tells us how a parabola it, it is to obtain a certain value within the range of values. The area under the PDF curve represents the total probability of all possible outcomes, which is always equal to 1. PDFs are very useful in statistics and data analysis because they allow us to calculate the probabilities for continuous variables such as time, distance, or temperature. They are also helps us to compare different distributions and to identify patterns or anomalies in the data. For example, if we have a data set that follows a normal distribution, we can use its PDF to estimate the probability of observing a value within a certain range or to calculate the mean and standard deviation of the distribution. What is cumulative distributive function? Cumulative distribution function is a mathematical function that describes the probability of a random variable taking a value less than or equal to the given value. So coming on to the next one, moment and measures of central tendency. Measure of central tendencies are statistical values that represents the center of or typical value of a dataset. The most common measure of a central tendency are the mean, median, and mode. The mean is the arithmetic average of all values in the dataset, while the median is the middle value when the data is arranged in an order. The mode is the value that appears most frequently in the dataset. So CQs or kurtosis. What is the meaning of it? So sequences or kurtosis are the measures of a shape of a probability distribution. Sequence measures the degree of asymmetry of a distribution, while kurtosis measures its degree of peakedness or flatness. So applications of probability distribution. Probability distributions plays a more crucial role in many fields, including finance, engineering, medicine, and social sciences. In finance, the probability distribution are used to model stock prices and interest rates and estimate the risk of associated with the different investments they have done. In engineering, probability distributions are used to analyze the reliability of a systems and predict the failure rates. In medicine, probability distributions are used to model the spread of disease and estimate the effectiveness of the treatment. In social sciences, probability distributions are used to model human behavior and analyze the survey data. Understanding probability distribution is essential for decision making and risk management. By knowing the probability distribution of variable, we can make more informed decisions and minimize the risk associated with our choices. For example, if we know the probability distribution of a stock price, we can make a better investment decision and avoid unnecessary losses. Similarly, if we know the probability distribution of a disease, we can take preventive measures and we can correct the problems which have been occurred in the medical field. Conclusion. So let us conclude the topic probability distribution today. In conclusion, probability distribution is a fundamental concept in statistics and data analysis that allows us to model more and understand the uncertainty and variability of a real world phenomena. We have seen different types of probability distributions such as binomial, Poisson's and exponential distributions can be used to describe various scenarios and make predictions about future outcomes. We have also discussed the importance of probability density functions, cumulative distribution functions, and moments. Measures of central tendency, sequences, and kurtosis as tools of analyzing and interpreting probability distributions. Moreover, we have explored some practical applications and more probability distributions in fields such as finance, engineering, and medicine, social sciences, where it plays a more crucial role in decision making and risk management. So here in this presentation, we conclude our topic by this conclusion and hope you all enjoyed our video. Please do like, share and subscribe our channel. Please don't forget to hit the bell icon. Thank you. This is the topic for today, guys. I am Kishan Bharadwaj signing off. Bye bye.